Hello, this is Mr. Gilmore with the 4.1 Parallel Lines and Transversals lessons. Just like any beginning of a chapter, we're going to introduce several new definitions. In particular, we'll be looking at parallel lines and transversals, obviously from our title, but we're also going to see what happens when a transversal intersects two other lines. It's going to form new angle relationships, and we're going to define those as well. Let's jump into our definition of what a parallel line is, or what parallel lines are. By definition, parallel lines are coplanar lines that do not intersect. It's important to have the word coplanar because, as it turns out, in our space that we work in, there are such things as lines that do not intersect but are also non-coplanar. We call those skew lines. So we'll just be very careful to make sure that in our definition, we do include that definition of coplanar, that term of coplanar in our definition for parallel lines. We have a symbol to represent what it means for lines to be parallel. It's this little symbol that we have in between these two lines A and B. When we write that little symbol, it really reads as the same as saying line A is parallel to line B, is how we read that. In a diagram, how would we represent the two lines being parallel? We place arrows on each of the pairs of lines to represent that the lines are in fact given to us as parallel. If I were to say I had a second pair of parallel lines that I also wanted my reader to denote that they were parallel, say I have lines L and M here, I could put a double set of line arrows on them to denote that I do have one given set here, H and J are parallel, but I have a second given set of parallels L and M. So we can represent that symbolically with our lines, but also in our diagrams we can represent them by symbolically with the arrows. Now let's talk about what a transversal is. By definition, a transversal is a line that intersects two other lines at distinct points. Now, those two other lines that they intersect at, it doesn't matter whether or not they are parallel or not. We are going to look at both cases. Today, we're just going to simply look at what's the relationship if the lines are parallel or not. We're going to say that the lines don't have to be parallel today, but in future cases, we'll be looking at what if the lines were parallel and we cut them with a transversal. In the diagram below, we have transversal T. This line T here is our transversal. It's intersecting the two lines H and J. So we would consider then T a transversal. Now, one thing we're going to be seeing come up here in a little bit is notice that at each intersection, we form four angles. There's an intersection of four angles formed here, and at this intersection, four angles formed there. We're going to be looking at what are the relationships of those 8 angles together, and we're going to give some angle relationships some names as we progress through this lesson. Now, of course, it is a relative matter on what we consider to be a transversal. For example, we just saw T crossing through H and J. But if we were to extend out lines H and J and those happen to intersect, then it becomes a relative matter of which line is a transversal. Now, here's the thing. All 3 lines in this diagram are considered a transversal, but not at the same time. If I picked line T to be the transversal, that means J and H I would consider to be the non-transversals. However, if I picked J to be the transversal, then H and T become the non-transversals. And then lastly, if H was the transversal, then J and T would be then the non-transversal. So again, it's a relative matter. It depends on which line, of course, we call the transversal first. Now we dive into the relationships of the angles that are formed when a transversal cuts through 2 lines. So we're using this diagram a whole lot, this diagram where T is our transversal cutting through our 2 lines M and N. So if we consider T our transversal, M and N are our non-transversals. Note then that each intersection we have formed 4 angles at each intersection, so a total of 8. What we do then first is we then separate these angles into 2 different categories. If we take a look, M and N being our non-transversals, there's a space between the 2 lines and space outside the 2 lines. So when we look at the space that's in between the 2 lines, we give the names in between those known as the interior angles because they are in between the sets of lines M and N. But there's also a set of angles that are not between the 2 sets of lines M and N, which means we call those exterior angles. So in our diagram below, we have angles 3, 4, 5, and 6 known as our interior angles because they're in between the 2 lines that are cut by the transversal. And then we have angles 1, 2, 7, and 8, which are not in between, which means that we consider those the exterior angles. Now, the one thing you'll be seeing today, yes, we have these 8 angles labeled, but the one thing we're going to be seeing today is it's not necessarily about the name of the angle, about where the name is of the angle, but it's the location of the angle. That's going to be the important part, because I can take these 8 names and rearrange them as many times as I want, but it depends on the location of where the angle. That's where we diagnose it, whether to be an interior or exterior. Now we're going to dive into 4 special angle relationships that unfold with these interior and exterior angles. Let's talk about our very first one, known as the consecutive interior angles. Consecutive interior angles, by definition, if we take a look at the top here, are 2 angles in which they are interior, which means we've already narrowed it down to being only 4 angles in the diagram. It could either be 3, 4, 5, and 6. We're excluding 1, 2, 7, 8 because those are exterior. So when they are interior and lie on the same side of the transversal. So down below, if we take a look at the 4 angles that are interior, 3, 4, 5, and 6, each of these can be broken up into pairs. And so you're going to see that each of these angle relationships are going to follow the relationship of a pair, like we've seen earlier in, like, let's say chapter 1 and chapter 2. We have linear pairs, vertical angles, supplementary angles, complementary angles. All of these angles are in pairs, just like the consecutive interior come in pairs. As it turns out, angles 3 and 6 are a pair of consecutive interior. They're interior and lie on the same side of the transversal. Same story about 4 and 5. They are interior and they lie on the same side, which means we have 2 pairs of consecutive interior angles. Now we also have alternate interior angles. Notice we actually have to add a little bit more to this definition than just being interior or on the same side. What we have to add here is that we also need the angles to be non-adjacent. So let's dive into the 3 things that actually happen in alternate interior angles. The first thing is these 2 angles that we pick have to be interior. That's the first thing. They have to be interior angles. The second thing is they have to be a pair of non-adjacent interior angles. And the third thing is they have to lie on opposite sides of the transversal. Okay, so let's dive into our interior angles. There's still 3, 4, 5, and 6, but we need to be non-adjacent, which means it can't be 3 and 4. It can't be 5 and 6. Those 2 pairs are adjacent to each other, which means they need to be non-adjacent. Well, that would then mean 3, 6, and 5, right? If I pick 3, it's not adjacent to 6 and 5, but they have to then lie on opposite sides of the transversal, which means our pair 3 and 5, they are a pair of alternate interior, and we have a pair of another set of alternate interior, 4 and 6. So those are another set of alternate interior angles. Notice they come in pairs. So in this case, 3 and 5 and 4 and 6 are alternate interior. We also have something similar to alternate interior. We have alternate exterior. Now we move to the other category of angles. We move away from our interior angles, 3, 4, 5, and 6, and look at our exterior angles, 1, 2, 7, 8. It's very similar to our alternate interior because you're going to notice there's 3 things. We have, first of all, they have to come from the set of exterior angles. That's the first thing. Second thing is they have to be non-adjacent to each other. And third thing, again, they have to lie on opposite sides of the transversal. So if I were to look at angle 1, that's one of my exterior angles. Angle 1 is exterior, good. It has to be non-adjacent to another exterior angle. Well, it's adjacent to angle 2, which means it's not adjacent to 7 and 8. And then it has to lie on opposite sides of the transversal. Well, then 1 and 7 would be our pair of alternate exterior, and 2 and 8 would be another pair of alternate exterior angles because they're exterior angles, they're non-adjacent to each other, and they lie on opposite sides of the transversal. So very similar to how alternate interior angles work, except we're dealing with our exterior angles in this case. Now we move on to our very last set of angle relationships. These are known as corresponding angles. Corresponding angles. Let's dive into what a corresponding angle is. First off, the 2 angles that we pick have to be non-adjacent angles. That's the very first thing we have to know about these 2. The next thing about these is there's 1 interior and 1 exterior angle in this set, which, as you see, we now have 4 angle pairs because remember there's 4 interior, 4 exterior. If we're picking 1 of each, that means there's 4 pairs of angles that we can make. And the last thing is they have to lie on the same side of the transversal. So let's let me show you one pair of what we call corresponding angles, and you'll see how you pick up the other three pretty quickly. Let me pick angle 1 to start with. Angle 1, I need to find a non-adjacent angle to it. Okay, so that means it can't be angle 2 or angle 4. It also must mean if angle 1 is the angle I picked, that's an exterior angle. I have to pair it with an interior angle. Well, I can't pair it with 3, or I can't pair it with 4. Okay, it's adjacent to it. And I also can't pair with 3 because it has to lie on the same side of the transversal, which means I can't be 4, those are adjacent, can't be 3 because they're on opposite sides, and it also can't be 6 because they're also on opposite sides, which then leaves me with only one interior angle I can pair it with, and that's angle 5. Note that if you take a look, angle 1 and angle 5 are also another way of thinking about it. They're in the same location depending on our transversal. They're both on the same side of the transversal and above their respective line, which means 1 and 5 are considered corresponding angles. Now that you see 1 and 5 are corresponding, then it's pretty easy to pick out the other pair of corresponding angles. For example, if I were to pick 2, then it can't be 3 and 4 or 1, and it can't be 5. It means it has to be 6 because they're on the same side, they're non-adjacent, and one's interior and one's exterior, which means our second pair of corresponding angles there are 2 and 6. And I can repeat that pattern. 3 and 7 are a pair of corresponding, and then 4 and 8 are our last pair of corresponding angles. So with corresponding angles, it's kind of a special case because you actually get 4 pairs of angles, whereas alternate interior, alternate exterior, and consecutive interior, they only have 2 pairs each in those. So now what we're going to do in these last several slides is actually figure out what relationship the angles have, if any, by picking out a pair of angles out of this diagram. So I note that the diagram has lots of intersections, which means, again, relative matter. It depends on what your transversal is going to be, right? If I were to pick M as the transversal, that means A and B are the non-transversals. If I were to pick N, it would again mean A and B are non-transversals. And of course, I could pick A and B to be the transversals, which then means M and N are the non-transversals. So here's what's interesting. Depending on which is our transversal, some angles could be either interior or exterior, depending on our perspective. So for example, if I were to look at angle 2, right now, if I were to consider the transversal M, angle 2 then would be on the interior. It's in between our lines A and B. But if I were to actually consider the transversal A, then 2 would be exterior to our lines M and N. So you have to be very careful, depending on your perspective, where that angle is. Is it exterior or interior? It depends on which transversal. We're looking at the angles 2 and 6. We're trying to determine, is there a relationship between 2 and 6? Well, let's dive into what they are. They're non-adjacent, they're on the same side, and it depends on our transversal. One is interior and one is exterior, which means angle 2 and angle 6, we would consider them to be corresponding angles, that they fit into that definition of corresponding. Which is then the transversal? What's the transversal to do? Well, it's an easy question to ask. What do the lines share? Or what do these two angles share? They share line A, which means A would be the transversal in this case. So they're corresponding angles, and A is the transversal. Let's do this again with the same diagram. Let's find out what are some other angle relationships we have going on in here. This time I pick angle 2 and angle 15. Let's dive into what their angle relationship is, if any. Well, first of all, I notice they're on opposite sides of the transversal, and they're non-adjacent, which means if they're on opposite sides, they're non-adjacent, and they're in between lines A and B. That means they're both interior angles. I have a pair of alternate interior angles. So they're alternate interior. So what is their transversal? Again, the question is, what line do they share? They share line M, right? Both of them are created using line M. So M is the transversal in this case. So they're alternate interior angles with the transversal of M. Now I pick angle 15 and angle 9. Let's take a look at those two. Well, first thing I note is that they're on the interior between lines M and N, and they're on the same side of the transversal. We have a name for that. That is consecutive interior angles because they're from the set of interior between M and N, and they're on the same side, which means they're consecutive to each other. And they share line B, which means line B would be the transversal of those two angles there, angle 15 and angle 9. A couple more examples. Let's look at angle 7 and angle 11. Angle 7 I first know, and angle 11 I first know, they're on opposite sides of the transversal, right? They're opposite sides of each other. And in this case, if we consider them to be lines A and B, that means 7 and 11 are on the exterior, which means they are a pair of alternate exterior angles. I'm going to shorten that up, alternate exterior angles. So what's their transversal? What line do they share? Line N. Okay, they share line N, which means that is their transversal. I have one more example. Let's look at 8 and 15. 8 and 15. Well, I first note that the 8 and 15, they're kind of far away from each other. A lot of students will think, well, if we think about them being the same location, one is exterior, one's interior, couldn't those be considered corresponding? Couldn't they be considered corresponding angles is really the question. That question is no, they're not corresponding. Here's the reason why. Let's answer the second question first. What's their transversal? The question is, what line do they have in common? Well, they don't have any line in common. And since there is not a line in common, that means there's no relationship between the two, because we have to have a transversal in order to relate the two. Here's a quick question for you. 8 and 12, do they have a relationship? Yes, they are corresponding, right? Those are corresponding. What about 12 and 15? Do they have a relationship? Yes, those are also corresponding. So now my question is, does the transitivity apply to corresponding angles? Transitivity corresponding? If 8's corresponding to 12 and 12's corresponding to 15, does that make 8 and 15 corresponding? No. Transitivity corresponding is not a thing. They have to have a transversal in order to be considered a relationship of angles. So since these two angles do not share a transversal whatsoever, that means they do not have a relationship with each other. This comes to the end of our first lesson, 4.1. Be sure to be working on the 4.1 worksheet. If you do have any questions on that worksheet, email me. I'll get back to you. With that, be good and do good.